Assalamualaikum and good morning to the lecturers, Dr. Zahir. My name is Muhammad HAIQAL, Bmma ZAINUDDIN. My matrix number is B0921104118. Today, I'm going to present about Lab 1 for the subject braking system. Lab 1 is discussed about to design and analysis disc brake. Our objective for this lab is to design the disc brake in virtual reality. Next, to define material properties of this brake rotor and to analyze this brake rotor based on brake force. This brake has a metal disc or rotor instead of drum. By using a CATIA V5 software, we have designed and draw the required disc brake for this lab. Next, I'm going to pass to my friend on the next slide. Thank you.
Thank you to my friend Muhammad HAIQAL explaining about the first sketch of our design. And my name is FIKRI and I will talk about the final design after we follow each dimension of the lab sheet that was given to us. Okay, next it is about applying material. CATIA software has already given us many material that we can choose, such as aluminum and minimum. But after many consideration and discussion from our group member, we actually choose titanium for our brake because from my group opinion, titanium is actually suitable for wide range, wide range application and highly resistant to chemical. I think that's all for me, and my friend will continue about in the next slide.
Assalamualaikum. My name is YUMNI RUZAINI bin AHMAD. Firstly, I would like to thanks to my two friends because explained briefly about the design of the disc brake and also about the material that we apply, which is titanium. Then I would like to explain about the force that we apply. We apply load about 2,680 kilonewton to the surface of the brake pad, which is look like in the picture that from the top of the surface and the bottom of the surface. This is about our defined material properties for our rotor disc brake. Firstly, the young modulus, we got the value about 1.14 exponent, and the Poisson ratio is 0.34. Also, the density is 4,460. Thermal expansion, which is 9.5 exponent 006, and the yield strength we got 8.23 exponent 008. And lastly, which is the material we use, titanium. Especially the titanium is we use titanium alloy. Next, this is our result of the von Mises traces. We got the maximum value is 2.36 exponent 11, and the minimum of the von Mises traces we got is 1.5 exponent 09.
Okay, thank you to Yumni for the presentation. Assalamualaikum. My name is Muhammad HAFIZUDDin bin SAMSUDIN. I will present bond mixture stress. As we can see from the picture, we can know the maximum and minimum bond mixture stress, which is the blue one is the minimum and the red one is maximum. Okay, from the analysis, we also can get the translational displacement. From the picture, we can know the maximum and minimum displacement from the analysis in Katia. Okay, the last one, from the analysis, we can get the result for the stress and deformation. First one is the maximum one mixture stress. The value is 2.36 exponent 11 Newton meter per square. The number 2 is minimum one mixture stress, 1.54 exponent 9 Newton meter per square, and the last one is translational displacement, 0.363 millimeter. Okay, thank you for me.
Assalamualaikum, my name is ALIMI. I will explain about factor of safety on this dash and on this analysis. For the factor of safety formula, we can see yield of strength divided by ultimate stress. The value as below, 8.23 divided by time power of 8 divided by 2.36 time the power of 11, and the value is 0.1736. According to our Katia drawing, the von Mises stress varies from 2.36 at maximum and 1.54 at minimum. We can affirm based on the data provided by the analysis that our this roto is not very useful because its factor of safety is less than 1, meaning it is at the permitted stress limit and cannot handle any further load at 0.1736. In conclusion, for the experiment, we have learned how to use CATIA to identify and analyze the brick design. Then we are able to simulate the brick design, which enable us to determine the highest and lowest von Mises stress and translational displacement values, so we can calculate the safety factor of the brake and the design that comfortable for all of the